Hello, everyone. This is Ryan Green with MLC CAD Systems. Definitely appreciate all of your time on the webinar today, and we look forward to showing you what we've got for our tips and tricks for faster machining series. What we're going to be talking about today is Mastercam's Mill-Turn product. So Mill-Turn is a product that's made specifically for the multitasking types of machines. Things like the Mazak Integrex, the Okuma Multis, things like that. And machines like this have their own unique challenges. So that's what the Mill-Turn product is meant to help you program for. So that's what we'll be talking on today. So what is Mastercam Mill-Turn? What it is it's an add-on to Mastercam Mill and Lathe. It basically combines the two in a way that makes it unique to these machines. Things that make it unique, such as like for a twin turret machine, being able to do things like pinch turning or synchronized operations. Things where there's more going on than just creating cuts. It's about orchestrating the flow, and that's what Mill-Turn is intended to allow you to do. So the first example, we talk about things like an Integrex. This one we're showing a DMG Mori type of machine. And you see that we've got operations happening simultaneously between the left and the right spindles. On this machine's particular configuration, it's set up using a B-axis milling head at the upper position while we got the lower turret at the bottom. But you can see it allows for synchronization like this. We had to park the turret out of the way to let the B head go more horizontal. So I'm going to get into showing how this stuff works with the Mill-Turn product, but this is one example of what we'll be talking about. Another example are machines like this. It's a Doosan TT series machine, just a twin turret type of lathe. So these kinds of machines, they've really got great potential. Here we're showing some pinch or balance turning, however you want to call it. And then we do simultaneous operations. The main thing of it is to take advantage of what we call the free cycle time. Having what we got running on the subspindle happening while we've got a part running on the main just really helps on cycle time. And I'll show you how we orchestrate this here in a little while. But to talk on the programs, the whole purpose of this product is to lay out these weight codes. So I just have a screenshot here of a dual stream output. Shows it putting in this case, it's the M900 codes. That's the weight codes to get things to synchronize. It lays this out. And it's done so in a graphical way. It makes it really easy to orchestrate these types of things using Mastercam Mill-Turn. There's also a variety of stock handling strategies, and that's what we're showing here. It can be the type of setup where you have a bar feeder on the machine, and you're doing a continuous bar feed where you're parting it off before you hand it off to the subspindle. You can also do situations where it's single pieces of the stock. Say it's too large to do a part off. You're going to load it, in the main spindle before you begin, and then it gets passed to the subspindle. You can also do strategies like you see at the bottom. Two separate parts. If you have some kind of job you're running where you have an A part and a B part, and both of them make a set, you can run it like that. Even for you guys in the oil field, whenever you have a part that's really long and it needs to be done with multiple pulls, so you can take advantage of the rigidity of the machine and then pull it, push it around as needed. You can also tell it whether that stock it begins in the left spindle or begins in the right spindle. So it's really easy to control for a variety of work holding strategies. The way the licensing works on this, as I mentioned, it is an add-on product, and it uses the code meter system to work with the machine environment. So if you've ever seen the code meter that's typically running in the lower right hand of your screen in the task tray, that has to do for for mill turn applications and licensing, that kind of thing. But like I said, at minimum, what you need is standard Mastercam mill and standard Mastercam lathe. And then, of course, you can have Mill 3D, you can have multi-axis, you can have the Curve Enduro 5-axis add-on as well. But the other component of this is, rather than there just being a post-processor, we've actually gone a step further with this, and we have now what we call the machine environment. It's a single file that's a combination of things, including the post. The machine environment file includes for the unique settings of your machine, and it's set to match the tool number, the tool numbering format, the number of stations you have on the turret. You have half stations, half indexes, and it also includes a simulation of that exact machine, because with all this going on, it's really tough to visualize the machining process. If you're waiting until you get to the machine to do trial and error, that's pretty risky. And it's good to be able to identify things before we get out there. And we'll talk some more on that here in a bit. Now, mill turn, it also applies to what we call our single stream simple mill turn types. I'm showing an example of something like a Haas DS30 machine. You can see that we've got the turret loaded up with Y-axis tooling. Notice the turning tools we have. You have cathode stations, and all this can be simulated with this mill turn products. A lot of these tools, when I've set up this demo file, see here it's warning us about we don't have enough projection on the part off. That's good to know before we go to the machine with this. But these tool models, I actually pulled them from machiningcloud.com. So it makes it really easy to get an exact representation. And then I've got these holders that are in the machine environment file to let us load this turret, so we can see an exact representation. It's great for planning. I mean, it's really easy to not realize that you may have a turning tool just one station over from a really long reach boring bore. You're going to run into clearance issues. We're going to run into that OD turning tool with a long boring bar right next to it, potentially hitting the jaws. So it's just a really great tool to have. The good thing about the single stream simple mill turn machines is that it doesn't require the full mill turn license. We'll talk a little bit more on that in a minute. But with mill turn, how it differs from standard Mastercam lathe is in the job setup. It's a more comprehensive job setup, and it's really critical that we assign all these things up front, because it does matter. What size chuck jaws we're using, how much stick out is there with the part. Maybe we're trying to program a part that goes in the through bore and it's bigger than the machine's through bore. Things that you could spend a lot of time making a masterpiece of a program, but then you find in the end you can't even use it. So job setup, it helps us determine all that up front. It makes it really easy to establish where your zeros will be set. Like for the left spindle, typically I set my Z0 at the base of the finished part, but you can also set it at the step in the jaws or some point in between. And then you can define where the pick off occurs when you're using that sub spindle to come up and pick the part off. Where is it going to grab a hold of before that before that part is transferred in, to the sub spindle? So that's all controlled through the job setup. Another thing is with Mastercam mill turn, it's built unique to these machines. It really has some cool functionality. What I'm showing here is a screenshot of just the contour toolpath, the milling contour toolpath. And you can see we got this tab in here that you don't see when you're in standard mill. It's the setup tab. This is where we tell it, what type of mill type is it? Are we going to be using the C-axis, or is it an axis substitution? Are we using a Y-axis to do milling on the face, or cross or do a plane rotation? And what's really cool is for the machines that use a B-axis head, if it's at some angle in between 0 and 90, with standard mill, we have to go in and create the tool plane. Well, with mill turn, it can derive that on the fly. Basically, if that geometry consists of at least two entities, two different lines, it can derive what plane that that feature is at, and take care of creating the tool plane as you see at the bottom of this window. And it's based off of the rotation the machine has to go to get to it. And I'll show some more of that in an example here in a moment. But where the mill turn becomes different than what you see in normal Mastercam is with our sync manager. The sync manager is, I refer to it as a secondary interface. Basically, what I'm doing in the main interface, I'm just focused on creating the cutting operations. I'm not concerned just yet about synchronizing things. I'm basically writing it as if it's just one cut happening at a time. And then we take that over to the sync manager, and it divides up your tool paths across the upper and lower streams, if you have a twin stream type machine. But you can see that it has a kind of like a Gantt chart at the bottom, where it shows you the sequence of events and the cycle time that it's going to take depending on how you've got things organized. And then when you need to synchronize these operations, it's simply a matter of drag and drop from one stream to the other. And when you do that, that's what's determining where those weight codes get placed in your program. So it just gives you just a timeline to view the whole thing. And then when you've got that timeline created, now we want to talk about simulation. So this is a screenshot of it, but from within that sync manager, you may have seen that there's a button that says simulate. This is what it launches into, and it's a simulation of your very machine. Of course, you can go in and hide out the machine housing. I typically hide out all but the kinematic components just so I can see it. But this is your virtual prove out of this, and so when you start running simulation, you may see areas improve. This is what lets you fix this up, and it also lets you see if you can change reference positions. That's another thing that you have control over, is you don't have just one spot to send a turret to change indexes. You can go in and establish new reference positions. Like myself, what I'll do is I'll set a reference position that's just far enough back to clear the longest tool, so the turret is really doing a minimum of indexing. But then sometimes I may want to move that turret completely out of the way. I can set indexes for that, or reference positions, that is. So let's see it at work. So we're going to switch over to Mastercam now, and I'm showing this in Mastercam 2019. This has been in Mastercam actually since X7, so it's been here quite a while. But we're going to talk about what we've got for present day. So I'm going to open up a mill turn file. We'll start with the B-axis type. So when I open this file, you'll notice, give it just a second, I'll see this Code Expert open up. A lot of you guys, with Code Expert, you may use it for your posted programs, but you may just choose to go to Simco or whatever. But with mill turn, it actually uses this Code Expert interface, as we'll see here in a bit. But for right now, though, let's take a look at what we've got. I basically just for fun, I downloaded a model of a Capto style turning holder. Thought I would make a toolpath or a program to actually make this. Great application for B-axis machine. And you see I've got my toolpath groups just like you'd see in standard lathe, where as I work my way down through it, I've got the roughing operations, milling operations, and things like that. This roughing operation, when you go to create this toolpath, on the toolpath parameters page, it still looks pretty similar to what you find in standard lathe. But what's determining what turret and spindle combination, that's controlled by what you select down here at the bottom for an axis combo. When you click on this, kind of looks right standard to, or it looks pretty similar to standard lathe. But this is where we're choosing whether we're using an upper or lower turret, if we're using the left or right spindle, that kind of thing. And that's what dictates what tools you see given to you in this menu. And then when we go to our milling operations, let's see, we've got the, we have this OptiRest toolpath that I'm using over here. And when you go and look into the toolpath parameters, we work our way down the list. We got tool, we got holder, just like normal, but go to setup tab, and this is where we have what's unique to mill turn. This is where we can choose it. Are we doing C-axis face milling? Are we doing Y-axis cross, which is what we're doing in this case? Basically, spindle's vertical over it, and we've got doing that work. And then we get a little further along to right here. I'm using dynamic mill to machine out that insert pocket. And that insert pocket is not parallel with the center on that tool. It is at an angle. So when I look at what we've got going on in here, and I go to that setup tab, you can see that I'm choosing to do a plane rotation. That's what it's basically a combination of a C-axis angle and a B-axis. And I got it set to derive from geometry. I didn't have to define a tool plane before I created this operation. It's able to derive it from whatever geometry has been selected, which is what we've got here. So a very nice feature of it. Just makes it really easy to take care of finding those tool plane angles. But after we've got all this done, like I mentioned, in here, all I'm really concerned with is creating my cutting operations as if I'm cutting one cut at a time. Now, ideally with these machines, I want to be doing multiple tasks, or as many as I can at a time. So what we do is we take that and we click what's normally the post-processing button. But when I click that, instead of creating code, what it's doing is it's sending this to the sync manager interface. That's what we're going to see pop up right here. So I'm going to expand this open so we can see it. So what's happened here is all the toolpath operations that we've got in the main Mastercam file, it's divided them into what's using the upper B-axis spindle, which is what we see here, and then what's using the lower turret. And if I go and just expand these open, eventually we'll see, like right here, there's a sync point. We've got sync 103. What I did is I had to synchronize this lathe point operation to not begin until after this Contour 2D is done. And I'll just show you how easy this is. Basically, I'll just delete only that one. So what I need to do is just take the end of that toolpath and synchronize it with the start of this one. And I'm just dragging and dropping this over. And when I do that, that's what creates that synchronization point. And if you look at the bottom of this Gantt chart, you can see if I go and delete that again, it's happening somewhere here along the way. That's what's determining the order, and also determining the cycle time that it takes to run this part out. So we'll go ahead and I'm going to click the save button so it keeps it all linked. Also in these operations, just expand it open a little further. At the very top, you've got options up here where you can control for different coolants. Like if you're going to have the shower coolant on the machine bed running, you can fill in fields like what you would have in the top of your NC file. Chip conveyor controls, different kinds of things that are unique to what to the particular machine type you're using. And then on the toolpath operations itself, say for this Contour 2D, I've got things where I can tell it what kind of approach strategy are we using. Is it Z first, X first, or do a direct? So it helps you get it around. Say if you have like a tailstock or a steady wrist, things like that. And you also have controls in here on the retract, on how it does its retract, and then where is it retracting to. This is where I'm talking about the ability to create these different reference positions and choose where to go there. But after you've gotten this done, the next step of this, at least for me, is I want to see a simulation. I want to see how this plays through based off of what we've gotten. So at the top of the Sync Manager window, so we got the post button. That's where we can finally create code, but we're not ready for that yet. We want to go and run a simulation. So what this uses, and you may have already played with this on the mill side, but Mastercam has the machine simulation interface we call MockSim built into the software, and it uses that MockSim platform to simulate what it is that we have set up so far. So we're giving it just a few seconds to initialize and get started. But I can have it show the machine housing if you want to see a representation. In this case, we're using a TMG Mori NTX 1000. Turn that simulation transparent, or my preference actually is just to turn it off, make it easier to see. But we go and click the play button, and based off of what we've got our settings at, that's what's going to control the order that stuff runs in. So even though I programmed it to run one toolpath at a time in the main interface, you can see over here, this is where I get to see, how's it going to play together. Is it going to be, okay to run? But in my line of thinking, I mean, if I owned one of these machines, this is what I would want to see it doing. I don't want to do just one cut at a time. If I've got dual stream capability, I can use it to do two streams at a time. So really cool stuff on that. Now I'm going to switch over to a different example. This was the example of using a B-head type machine. So we're going to switch over to a dual turret style. So we've got the Doosan demo file. That's what we'll look at here. So on this machine, or on this file, it's really just simple, more standard turning and live tooling work. There's no compound angles involved in this. It's perfect use of the twin spindle type of machine. So another thing I want to look at, with these machines is if we can optimize the cycle time, the total run time of it. And that sync manager comes in really handy for that. So I'm sending this over to the sync manager, and just like before, it breaks it down per stream, like what we see here. I'm going to kind of condense the view of this just so we can see the entire runtime start to end. So it's telling me cycle time is 7 minutes and 20 seconds. And what I'm looking at in here is I'm looking to see if the more you could spread that runtime equally across the upper and the lower turrets, that's really the more benefit to the runtime for you. And I look at this and I see that the lower turret is done with its cycle time almost 2 minutes before the upper turret is done with its cycle time. So that makes me think, well, maybe I can take some operations that are running on that upper turret, maybe I move them to the lower. But I have an even better way of this. One thing I look at is the roughing time. That block of time right here. That's where it's rough machining. The profile on the main spindle, and there's looks like almost a minute and a half of time tied up in that. So with mill turn, I can go in and do pinch turning out of this. So let's take that cut, for instance, and it's this one right here. It's operation number 16. So I'm going to zoom in a little closer at this. I go in and have a look at it, and right now it shows that we're set up using the left spindle upper turret. So I want to see if I can make the lower turret come in and help us out with this, get this run out more quickly. So what you do is you first create what we call the parent roughing operation. You create the parent op first, and then with the red arrow immediately following it, that little insertion arrow, I'm talking about that thing you can drag and drop, anywhere within the file. That just determines where the next toolpath to create is going to go. But up here in the turning groups, you can see that you've got something up here that you don't have in standard lathe, and that's pinch turn. So we're going to take this pinch turn operation, and they make it really easy. What you have to do is select first, what axis combination you're wanting to use. And I know I'm already using the upper turret. So that means that I use the lower turret for this pinch turn operation. So I go to my axis combo, and I go and select the left lower. And then I've got a tool already defined here. So it's another thing here. Obviously, you would need to make sure that both tools, on either turret, they're defined for proper spindle orientation. It goes out saying that they have to be, mounted for whichever way it's turning. So if it's on the upper turret and the insert is orange, that means you're turning an M3. And if it's on the lower turret and insert's yellow, that means it's M3, turning just like the upper. Just the insert on the lower is facing you. Insert on the upper turret is facing away. But anyway, we choose that tool, and then we go to the pinch turn tab, and it's very easy. We just need to select out of our toolpath list, that roughing operation, which is number 16. That's what we're going to make into a pinch turn. So we've got that selected. The next thing is you can choose either do pinch turning or balance turning. Pinch turning is where the first cut, like in this case upper turret, is going to start a half a second sooner than the one on lower, just so they're not right at one another. You've got different options for controlling that. Another option is balance turn. Basically, these cuts are on the same pass as each other. We're just doubling the feed rate. It gets through more quickly. If any of you have ever encountered, having chatter on a long parts where there's not much support in the middle, if you've got these kind of machines, you can use this to counteract that flex, that chatter it's occurring. It neutralizes the force that it's up against, and it really helps you get better finishes and things like that. But we can tell here to do a bounce turn on first pass only, or my preference is to have it bounce turn every pass. So click OK to that. And it still looks like it's running one tool at a time, but don't let that fool you. Of course, we need to go in and regen the rest of our operations so that they jive with it. While that's regenning, I'll just go back. I just want to review again. You see on the sync manager how the cycle time is right now when we're roughing with only that upper turret on that part. Total cycle time 7 minutes and 20 seconds. Well, now we've made this change, we're going to resend this to the sync manager. And we want to see what difference this has made. So yeah, I mean, this is much better. I mean, look at this. If I go and condense this down again, we've just about got the cycle time, equal from one turret to the next. We eliminated that almost 2 minutes of time with the lower turret sitting idle. Let us spread this out, and each of these red lines, those red lines indicate synchronization points. So let's have a look. Let's see how this plays out. So we click the simulation button. Let this start up in the mock sim interface. Myself, my preference is just I've used simulation big time. I don't want to have an expensive surprise at the machine if I can just have a pretend surprise here on the computer and not have cause any damage or any downtime. Very important tool. These machines aren't cheap to fix. So we'll go ahead and run this and have a look at how this is going to play for us. First thing on this part file, the way I set it up is it's doing the stock full beforehand. So you'd have to imagine the part was already complete in the main spindle to begin with. This is where we go and pass it to the sub. This shows a breakdown of the process. Shows it feeding in. Even shows the chuck jaws opening and shutting. And it's doing this while this is spinning. It's really important to keep the part spinning during the transfer, because if it's sitting idle, sitting still, that's a chance for a chip to be on the jaw and you grip on the part over that chip. We don't want that. Keeping it rotating keeps that kind of stuff from happening. So we got it pre-pulled. Next thing is we'll come in and do the part off. So like I say, you have to imagine that part in the main was already done. So now we're going to work the other side of it when this guy retracts back to the home position. But here comes that pinch turn that we've set up. So it's got the first tool in position and it's waiting. Remember, we've got the wait code here. It's waiting for this other one to get there. And then when they meet, now we've got it running both of these guys at a time. There's really, that's where most of the metal removal is occurring on this part anyway, is that. So now that roughing is done, now the lower turret can go back to handling the work to be done on the subspin. Very cool. And you can see how we can simulate the approach and retracts. Right there, having the direct approach rather than Z first or X first. That could be potential for a collision. So it's really good to know this kind of thing ahead of time. Another thing to point out is how you can load the tools onto your machine's turret. So if we go back into the standard Mastercam lathe interface, the regular interface, You guys may have seen these buttons in the toolpath operations tree. You've got setup tools on machine, and you've got reference positions. Well, the reference positions, that's where you can go in and create new reference points. This one, I don't have any custom ones created, but if you want to make a custom ref point, you can right click in here and say make a new reference position. You can give it a name. The name you give it here is what will output in the program. And then you can go and set where is this reference position in X, Y, and Z. You set it at the C angle, the spindle needs to be turned a certain way. You can set that as well. This tool is really handy for you guys. So you've got the deep reach boring bar on that Integrex, and you're going to be doing boring work on the sub spindle. Well, that tool comes out of the tool changer pointed to the left, and we got to get it turned to the right. This is where you can have that back that B head all the way over to the right end, then start swiveling simultaneously in B so that you don't hit apart with that tool as it comes around. Really cool stuff. But other things in here is the tool loading. So when you go to the tool loading, again, you only get this in the mill-turn product, but I can go to that lower turret and just view all the components on it. I can see how it's loaded. And if you've ever finished your program, go to the machine, set up and run, and you realize that the way you got it numbered is not going to work. It's kind of a frustrating thing. This allows you to see all that up front. You can see if you got your tools positioned where it's needed. Things like this riding wheel drive live holder. It's pretty bulky, so I probably want to keep it far away from from the more short projection types of tools. You can also go in and set projection lengths. Take this one here, for instance. So we can right click on it, set projection length, and it shows you a model of that tool, and this is where you can go in and change, where is this guy set at? And this can be carried over to your setup sheets. You can have a setup sheet where it details the operator exactly how to load it, what kind of projections required. You may have seen earlier in my video of the Haas DS30, I didn't have my part off blade sticking out enough. This is where I can go and adjust for that. So it's a nice feature to have on things like this. But after you've gotten all this stuff done and you're back over this interface, because I made changes, it won't let me post yet because it's that little lock button. It means that this is disconnected now from any new changes I made over here. So no problem, we just resend it to the sync manager again. We get this guy sent over, and let's say we're happy with how things are running now. So now we're ready to generate some code out of this. So we'll click the G1 button to post some code. Looks like everyone's still with me, so doing good. And this is the dual stream output. This machine basically is running two programs. As I go through this, it automatically shows me the extents of the program, extents in X, Y, and Z. I can hide that out for now, but I can as I hover over weight codes, like right here, I'm just hovering over my mouse. It puts a graphical view, shows you where it's linked to the corresponding weight code in the posted program. I think it's a little bigger, the zoom. Yeah, so as you work your way through it, you can go in and have it go from one sync to the next. Just work your way through it. This is a good way for you to look through your code after it's posted, and you can see how things are lining up. This right here now, I can go and hover over that, right click, and I can bring the matching sync point into view. See, I've got all these weight codes happening one after the next. This is that pinch turn operation we made. This is where it's using a tool on the upper spindle or on the upper turret and the lower turret to simultaneously rough it out. I mean, imagine writing this out manually. I don't even want to think about it. It's all about making it easier for you. And then, of course, when this is done, that's when you can take the file over to your machine and begin to run it. So that's what we've got to talk about on the dual stream mill turn machines. Let's talk about those of you out there that have machines such as the Haas DS30Y, and I'll point out that we also cover for the Haas ST series machines, the single spindle, non-dual spindle machine. We cover into that as well. And to kind of talk back on the licensing, machines like what I'm showing here, this is a true mill turn, multitask machine. It requires a mill turn license, and it also requires a license for the machine environment. And you'll need a machine environment per each type of machine you've got. Now, if you've got a shop full of the same Integra 400, then you only need one machine environment. So if you got an Integra 400, you've got a Kuma Multis B400, a Doosan MX, those are different machines, those require different machine environments. But with the simple mill turn, and we're going to open up a file that helps us, illustrate what I'm talking about here. Simple mill turn, it doesn't require a mill turn license. It does require the machine environment, but because there's no way to do, it's not possible to synchronize operations on a machine like this. We just have just what we call the simple single stream machine. So on this one, this is where I got creative, and I had gone to machiningcloud.com and I downloaded all these models of these tools. Waiting on it to pop up here. I guess it's loading it up for us. But these days it's more common to find these machines outfitted with the Capto style holders. You can see on this one here, I've got just for station number 9, got a dual holder. This machine has a Y-axis, so we can go off center and Y to get to one tool or the other. I don't use up so many indexes on my machine this way. And I've got some others, like right here, I'm just using the single station. This particular machine, it also supports for half indexes. So here we've got a center drill loaded, and right next to it in that half station is the drill. If it supports for half indexes, take advantage of this stuff. Really helps you get a lot more cutting tools on that turret. And so here I've downloaded everything, including the grooving tools, and it looks like a real groove tool. Like I say, this is all from machiningcloud.com. You can also go to sites like Sandvik, Coral Plus. Anywhere you can get the 3D model, it really helps out on letting you more realistically simulate this kind of stuff. So I'm going to hit enter to return back to here, and then look at from this view, I'm going to show my reference positions. So you can see here, the grayed out reference points are just the standard ones. That's things like your G28, U0, W0, just the machine home. We've also got park positions, but I've made these other ones. I've got sub for that long drill. I wanted to have the turret, move away 8 inches before it indexes to it. And then when I'm using my short rigid tooling, I just set a close tool change position for the sub where it's backing off a real minimal amount. Same thing on the main spindle and all that stuff. And where that corresponds is when I go to send this to my sync manager. Let this come out here for us. So in the sync manager, you notice now there's just one stream. Those other files there was 2. Well, because this is there's only one turret on this machine, so we only need one. But as I go through these, I can look at each operation, expand it open. I can set a reference point from where it begins and where it goes to at the end. So right here on the retract of that, I have it going to that closed tool change rather than all the way back home. Over a run of several hundred parts, that travel back and forth to home holders, it really adds up. So the closer you keep that dude in, the better you do on time. Just obviously it's very important that the machine is set up right. I want to make sure they understand, they can't have tools hanging out any more than wherever you specify on the stick out length. But it lets you go in control for all this. Just makes it really nice. And because on machines like this, creating the tool paths is one thing, but then the other thing is getting them to play with one another properly. These reference points and stuff. So it's maybe not. It doesn't make as much sense to just set one really long reference point because you got one long tool in the machine. This way you can set it unique from one to the next. Of course, down here we've got the play out of the process, and there's just one stream. We only have one turret to use, but I see these machines a lot of places I go, and this really gives you a nice means of being able to control for these and having a much more visual way of doing it. So we're going to show the machine simulation really quick. That machine simulation, it loads the turret in there just as you'd loaded in the main interface. It has all the tools in position as they're needed. It just gives you a chance to see. Now, right now it's still loading, so we'll give it a second here. We'll see all these guys still out. But just having this alone, this can be saved as a presentation file, so it can be put on a computer out in your shop. You can even run it on your computer in the lobby if you want to just give a cool show for your customers as they come in. But go and play this through. Just gives me a chance to see how it's going to happen. So you can see here, we're taking advantage of the twin station turning tools, using one tool to rough it out. And then after it's done roughing it out, it just moves over in Y to the next tool. That's what we're doing here. So, no need to index it. It's really easy to run out of room on the turret of machines like this, especially when you've got several different tool types on it. But just really handy. And you can see that it's let me plan for everything. I've got the stick out links on the step drill, the part off blade, all that good stuff. Here we're doing the live milling on these flats. But really nice product. It's definitely a great way to speed up your machining time. So do you have machines like this? You have mill turns, and you want to find ways to be more productive than you are right now with them. We can definitely help. Now here's another question. What is the primary difference between Mastercam and mill turn? All right, so really, the primary thing the biggest thing stands out to me right away is how it uses the sync manager for posting. You can't just post code directly from Mastercam. It posts it into that sync manager. The other thing that makes it makes it different is the way that the job setup is and the way that the toolpaths interact with it. You may have seen that setup tab that we have in the mill operations. Things like that just really make it easier to derive those tool planes and stuff like that. Another one said, who should I contact to get my sync manager working correctly? You want to contact us at, either by phone to our Mastercam support line, or you can email to us. The number to reach us by phone is 800-364-1652, extension 3. That 800 number takes you directly to our main menu, and then extension 3 takes it to Mastercam support. And it's another one question here is like, how do you contact me directly? I'm on that line. If you call the support and you want to speak directly with the person, you can just ask for them if you like. But yeah, 800-364-1652. And then for email, because you may have a file associated with it, maybe you need us to read your email so we can kind of digest what you're saying is of issue. You can email that to us at mastercamsupport@mlc-cad.com. Again, that's all one word. It's all lowercase. That's mastercamsupport@mlc-cad.com. Another one is, do you have beginner classes? Yes, absolutely. We have monthly scheduled Mastercam Essentials classes in all of our offices. These classes are held in office because it does require that you have a training computer that we've got computers that are up to speed on all the hardware, software licensing, all that good stuff. And then we have Mill Essentials, which is a 3-day class, and we have Lathe Essentials, which is a 2-day class. And then for mill-turn training beyond that, what we want first, what requires you take our mill and lathe essentials first. And then mill-turn, it builds on concepts learned in that. So as far as online trainings, I know there's a question about beginner webinars. What we've got for that, and you can actually check this out directly on MLC CAD Systems website. We have Mastercam University. It's online training classes that you can take for up to 12 weeks. We have classes for 2D and 3D mill, as well as lathe. The classes are $249. It's a good value, especially if you want to take it on your own time. You can't afford to be gone from work, or you want to learn in the evenings. And it does include a free version of Mastercam that you can install in your home PC to allow you to, because obviously you have to be on Mastercam to be learning it. It's what we call the Home Learning Edition. All right, here's a couple of them. So where do you set the machine reference position and tool setup manager once again? Okay, so where you'll find that is in the main Mastercam interface. With this on my way. So in the main Mastercam interface, when you're in mill turn, you find those buttons right over here in Toolpaths Manager. Set tools on the machine and edit reference positions. I've got another one that says, are most parts designed in SolidWorks and then converted to Mastercam? Yeah, it really depends. I mean, Mastercam, you can draw from scratch and create 2D and 3D models. You can do that in Mastercam. Of course, if you got a CAD platform like SolidWorks, and that can be done as well. You can see when I go to the file open window, then we go open a file. When I look at the drop-down selection of file types I can open, you can see we've got all types. We've got the SolidWorks files in here. Bring in, if you use Rhino or Autodesk Inventor. We've got, AutoCAD based like DWG, DXF. And then we've also got the generic, CAD file types as well. There's others in here like CATIA, but, those are paid converters. Those are the ones that you have to pay for a license for, but ones like SolidWorks, Inventor, those are free with it. It already comes with it. SolidWorks, it has really powerful design tools. So if you're already familiar with working with SolidWorks, more than likely you'll be inclined to still do all your drawing in SolidWorks and then just import it over to Mastercam. Keep in mind that you've also got the ability to run Mastercam inside of SolidWorks. The only thing is, it's not available for mill turn. You can do standard mill or 3D or multi-axis mill, but not mill turn. Lathe in SolidWorks, but that is an option as well. Another one is, what is the Home Edition? Well, this Home Edition, I'll just show you. If you go to your browser, and I've got to rearrange my windows here real quick. Let's go in here and have a look at this. Go to my favorites. Yeah, so if you go to Mastercam's website, you just go to mastercam.com. That's what I'm about to go to here. You may notice that their website is pretty fresh. It's been updated recently. But if you go to that downloads link, you go in here, right here at the very top says, give Mastercam a try. Click here to request a copy of the Home Learning Edition. That's where you get it. So, check it out for sure. Another one here, I've got a question, send some info for the home classes. So anyway, just want to point out again, for those home classes, what you do is you go to our website. So we go here to, I've got it bookmarked as MLC CAD Systems, but it's really easy. It's mlc-cad.com. When you go to our site, this is where you can find information. You had talked about training earlier. We can go find information for training classes in any of our locations. But for those home classes, that's where you go to the store. You go to the store tab. It's right here in front. You can choose Mastercam U. And this is what we've got available for Mastcom University. Yeah, great question. It's a great way for you guys to train and not take up too much time out of your day, because in machining, I mean, you really need your guys there. So next one is, what is the best file extension to import into Mastercam? Gosh, it's hard to say. I mean, really varies. Depends on the CAD platform it was created out of, but my preference usually is Parasolid or Step. I try to avoid IGES files because they come into this trimmed surface model rather than a solid model, but sometimes it's all you got available. Another one here is, you see the VeriSurf tab at the top of my screen. So let's see here. Look back in Mastercam. Got this tab called VeriSurf. VeriSurf is a third-party product of Mastercam. It's a metrology package. This is where we can sync sync this interface with things like your CMM, or if you have a portable measurement arm, we offer what we call the Master 3D gauge. It lets you write those CMM programs, to pull it, and you can fill in all the G, D, and T data, or you can actually import it. If you're bringing CATIA files that already have MBD data within it, MBD, it stands for model-based definition. You have any customers that tell you like, oh, we don't have a drawing, all the info's in the model, and you may look at the model like, well, I mean, I see a hole. I mean, is that a tapped hole? Is it reamed? What's the true position? And they'll say, well, it's in the model. Well, you need to talk to us, because I've gone to customers before and I show them that it's in there. It's model-based definition. It actually puts the dimensions on the screen, puts the GD and T data. It defines what the datums are. And when you use VeriSurf, it ties into that. So if you absolutely hate writing CMM programs where you got to write in all the tolerance data, it can pull that from the MBD data within the file. So check it out. So the primary purpose of Mastercam is to take a design and make it. Yeah, that's pretty much it. If you're making it on a CNC machine tool, Mastercam, it's all about creating that code that you take to the machine, the code telling the machine how to make the part. But I mean, it's not the only thing it does. I mean, you can also design in it. We have lots of customers that are just job shops. They don't have a CAD platform. They just get a drawing over to fax machine, and they need to make it. So they have to draw it up again, basically. It's kind of counterintuitive, but that's just what it is for them. They can take the software and draw it up from scratch. They can create a 3D model. It's a full CAD/CAM platform, but you can import models as well. All right, so do you need a new post if you add mill turn to standard lathe? Yeah, you do. What we call the machine environment, and that machine environment corresponds with what your machine is. So you need to reach out to us, and we'll get with you with the right questions. We'll ask you, fill out a form where it details it. It's really important that we know exactly what you got on the floor. Another one, I have a Mazak 200MY with the programmable steady rest. How would I get a machine environment? Well, it's kind of the same thing. You need to contact us. We would get you the post form, get the right info from you, and then we'll see what we can do. It may already be available right now. I just don't know off the top of my head. Another one is you have the lathe module, but didn't know you could do dynamic paths. Do I need mill also? So with lathe, it has a tool path called dynamic rough, and you may have seen it in that one example of mine. You use a round insert, and it does it like a trochoidal, style cut to kind of carve the part away. Really great for applications where you're using ceramic inserts, or you got really hard material that just keeps notching your insert because of the steady, passes. But if you have live tooling on your lathe and you don't have the mill module, you'll be limited to what we have in a C-axis group. That's C-axis face drill, cross drill, C-axis face mill, cross drill, that kind of thing. But when you have mill on that lathe license, you can also use dynamic mill on your lathe. You have to be careful about how heavy a cutting load you put on some of these geared riding wheel head drives that you use for live tooling. It's a great way to limit that. So the next one here is how do you update SolidWorks part to Mastercam part? Same part but updated. Yeah, so if I'm working in two separate interfaces, I'm working in SolidWorks and then I'm working in Mastercam, and say I had to up-rev the part and I need to get that part into Mastercam, I don't want to just start over with a new file. What I'll typically use is on the File tab, you can use this function called Merge. It's basically like open, but it's just going to open that new part file into this part file, and you can have to reapply your toolpaths, obviously. But if you were using Mastercam for SolidWorks, you wouldn't have to worry about any of that, because when you update your CAD model in SolidWorks, everything stays associative. While the same is true of your toolpaths when you're running it in Mastercam. If you have a currently maintained license of Mastercam Mill or Lathe or both, you can run it within SolidWorks. It's simply just a download. You have to download the software. It is separate of the Mastercam download, but you download and install that. It'll show up in the list as an available add-in. That's what Mastercam, it basically runs as an add-in within SolidWorks. If you're an OEM type shop and you do design changes frequently, that's a real time saver. Okay, well, I guess that said, that concludes our webinar today. But please stay tuned. We have events all the time. We have them, webinars like this. We'll have events in our offices. We'll have rollouts. Keep in mind, we got rollouts coming from Mastercam 2020 around the August time frame. I'm not sure on exact dates yet, but it's coming, and can't wait to show you what's new. And if you don't already know, it's already out. Mastercam 2020 is already out. But thank you all again. We certainly appreciate your time. We'll see you next time.